I'd like to welcome everybody here to our dairy team webinar on mitigating heat stress for employees on the dairy farm. Our presenter today is Cody Volkmann. He is a certified safety professional with 13 years of safety and health experience. He is currently an occupational safety specialist with the College of Engineering and Environmental Health and Safety Department at Iowa State. He will discuss how dairy producers can mitigate heat stress for their employees. He will define heat stress, give us an idea of how it's measured, and offer techniques to prevent heat stress. So, as I always say, Cody, the podium is yours.
All right. Well, first of all, welcome everyone to this heat stress presentation, and thank you to Fred for inviting me here. As Fred said, I've been an occupational safety specialist in the safety industry for about 13 years now. Been at Iowa State over 7, and grew up on the family farm. So combining those two interests, this is a topic I've been working on for a few years, is heat stress. And so I'm excited to share with you all how heat stress is measured and really practical ways of what you can do to reduce the heat stress. Oftentimes we hear, well, we live in Iowa, it's hot outside, there's nothing we can do. And there are things we can do and ways we can help mitigate the heat stress for our employees. So what we're going to do today is we're going to define heat stress, what it is, and then we're going to talk about those contributing factors that factor into what the total heat stress load to a person is. And then we're going to talk about solutions and ways to prevent that heat stress. And I'm not going to go into detail on what is heat cramps, heat stress, heat exhaustion and heat stroke. We're really going to focus more on what we can do as employers or managers or supervisors on what we can do to reduce the heat stress that our employees are experiencing. Typically, when we see a heat stress training, it's just rehashing the heat cramps, heat exhaustion, what are the symptoms, first aid, etc. But that doesn't really offer us many solutions on what we can actually do that are practical to prevent it. And ultimately, heat kills people. Last year, I just saw a statistic that in the United States, 2,300 people died from extreme heat. Now, that's just not work environments. That's personal, work, all industries. But that was 2,300 people that died, which is more than the total people that died from tornadoes, hurricanes, or floods. So extreme heat is a really big deal. And the Occupational Safety and Health Administration is actually in its final stages of finalizing a heat stress standard that will put some requirements and regulations in place for employers to implement. And we just had our first little heat wave here in Iowa, so it's timely that we're having this. So what is heat stress? The technical definition of heat stress is the net heat load of exposure from the combined contributions of the metabolic heat, environmental factors, and heat loss to the environment. And throughout this presentation, we're going to dissect what each one of those 3 items are and how we can impact them. And as we go through this, what I want you to think about is how can you positively impact any one of those 3 things? And we'll break them down more here in just a little bit. But first, what I want to do is I just want to do a quick refresher of what heat-related illnesses are that you may see or experience. One of the most common ones is a heat rash, and that's most commonly from damp, wet skin in contact with clothing. People might break out with a small rash. Heat cramps, that's often related to dehydration and heat, depletion of water and electrolytes. And the 2 big ones that people often focus on are heat exhaustion and heat stroke. And we start to see heat exhaustion when a person's body temperature, core body temperature, starts to elevate. And when it gets too high, above 104 degrees Fahrenheit, your core body temperature, that's when we start to see the onset of heat stroke. And one thing I want to point out is heat stroke can be classified as 2 different types of heat stroke. There's what is called a classic heat stroke and what is also called an exertional heat stroke. Classic heat stroke is basically a heat stroke that a person experiences just because of the heat load from the environment. Think about if we're in this hot environment, we're going to enjoy it. We're on a beach somewhere, laying in the hot sun, and somebody has a heat stroke. They're not exerting or working. They get a heat stroke because of the heat load just from being out in the environment. We typically see that on younger people and older people because younger children and older folks aren't able to thermoregulate as well as average adult. Now, exertional heat stroke, this is what we normally see in work environments where not only do we have the heat from the environment, we have people performing hard manual labor. And what that does is that causes our bodies to increase our metabolic rate and generate heat. And with the combination of our bodies generating heat with the environment, our body is not able to quickly or adequately cool itself, and therefore we enter an exertional heat stroke. So when we go through this, just keep in mind there are two different types, and in the work environment, it's usually due to exertional. And we can help prevent those, and we'll talk about those mitigation strategies here in a minute. So when I went through the definition of what is the heat stress load for people, it talked about metabolic rate, environmental factors, and then heat loss. And so I like to look at heat stress as what are our inputs and what are our outputs. And so I broke heat stress down into three contributing factors. The first contributing factor is the heat that our body gains just from working hard. If you think about a performance athlete, or if you are working hard, or if you are exercising, your body temperature raises just because of the work you're doing and you start sweating. That is your metabolic rate. We also have the heat gain from the environment. As we've had the past few days, we've had high temperatures and high humidity, which makes it more difficult for our body to cool itself off through sweating and evaporative cooling. And so our body is going to start gaining heat because it can't properly cool itself. And then our output would be the heat loss from our body to the environment. Our body has physiological processes that allows itself to cool off, mainly sweating. And then if you notice when people get hot, they turn red. That's our body sending our blood to our capillaries to spread out the surface area to help cool off our core body temperature as quickly as possible. Now, when our body heat and the heat gain from the environment is significantly greater than our heat loss, we're going to have a substantial heat load, and that's where our employees get put at risk. So as we go through this, think about what work your employees are doing, what physical manual labor, think about the type of environment and the conditions, and are there any ways you can improve those? So in this aspect of an input, we would want to try to reduce the heat gain from your body or the heat gain from the environment, or we want to try to increase or help our body lose that heat to the environment. So as we go through that, think of it on that mindset, inputs and outputs. So let's talk about the heat gain from working, also known as the metabolic rate. So our body heat is generated from the intensity of our work. How fast or what is the speed of our work? How quickly are we performing that work? And what is the physical demand? The higher the intensity equals the higher metabolic rate equals more body heat gained. Essentially, the harder you work, the quicker you work, and how fast you have to do it, all contributes to the total heat that is generated. If you think about it like this, if you walk a mile in 15 or 20 minutes, that's not too difficult. You're probably not sweating. It's not as high of a demand. But now, what if you have to increase that mile from 20 minutes? You have to increase or decrease the amount of time down to 8 minutes. That is quite a bit more intense, trying to go from walking a minute in 20 miles and trying to run a minute in 8 minutes. The speed is drastically increased. It's a higher intensity. That means a higher metabolic rate, and therefore your body is going to generate more heat because you're doing more work or the same amount of work in a shorter amount of time, higher physical demand. So where does heat gain from the environment come from? Well, this is one of the variables that living in Iowa, we often hear is it's out of our control. It's just hot outside. There's nothing we can do. And there is some truth to that. It is more difficult to control because there are a lot of variables that we may not necessarily have control over. Are we working inside or are we working outside? And if we're working outside, are we working at a fixed location or are we mobile? Each one of those has unique challenges to it, but there are still some things we can do to try to control that local environment. And the main ones are ambient temperature and humidity. And those are really the two factors that determine a lot of the heat load just due to our bodies relying on evaporative cooling to help cool ourselves off. And to measure the environment, there are typically two indexes that we see. The most common one being the heat index. And there's also one called the wet bulb globe temperature, which you may not have heard about too much. We'll talk about the differences of those. And right now, the heat index is probably the most popular index you will hear. You get notifications on your phone. The news talks about it all the time. But what is this wet bulb globe temperature thing? This is a newer index, and it's what a lot of the regulatory agencies are using to measure heat stress. And we'll talk more about the differences between those two. So you may have heard on the news, or if you look at your phone's app for what is the weather today, you will see temperature and then the feels like temperature. That feels like temperature is usually the heat index. And the heat index uses the ambient temperature and the humidity to measure the level of discomfort a person may have. So even if it's 90 degrees outside with 60% humidity, due to the humidity combined with temperature, it may actually feel like 100 degrees to our body because it may not be able to adequately cool itself. So this is the most popular way that is communicated out through the National Weather Service, news and apps. It's just been in place a long time, and a lot of people understand it because we're only taking into account humidity and air temperature. So that is the heat index. Now, the wet bulb globe temperature. So from regulatory agencies, this is the most commonly used index for thermal exposure levels. OSHA, which is the Occupational Safety and Health Administration, the American Conference of General Industrial Hygienists, and the International Standards Organization, they have selected the wet bulb globe temperature as the primary means to measure heat stress in the work environment. So there are a few differences between the heat index and the wet bulb globe temperature. So the heat index, as I said, it takes into account ambient temperature and the humidity, and then you get the heat index. The heat index reading for the ambient temperature is taken in the shade. So we have temperature, humidity readings taken in the shade, where the wet bulb globe temperature, that reading is taken in the direct sunlight. And that calculation includes not only ambient temperature from the air, humidity, but it also takes into consideration solar irradiance, which is how much energy or how strong the sun is that day. What is that going to do to your body? And it also takes into account wind speed. And so the calculation is different, and it has more items included in it. I recently just had a conversation with the local National Weather Service about whether they are going to start including this wet bulb globe temperature on some of their communications, since it's going to be becoming more and more popular. And they said that it's coming and it's on the way. There's no timeline, but you will be seeing this wet bulb globe temperature more and more as regulations and standards continue to develop for heat stress in the work environment. So on this slide, what I wanted to do is I wanted to show you the difference between heat index calculations and the wet bulb globe temperature. So I have two scenarios on the screen here from a wet bulb globe temperature and a heat index calculator. If we look at scenario one, we have a max temperature of 95 degrees Fahrenheit, relative humidity of 50%, a wind speed of 6, and a cloud cover of 0. That gives us a heat index of 105 and a wet bulb globe temperature of 88 degrees Fahrenheit. Now let's look at scenario two. Temperature is the same and relative humidity is the same, but let's look at our wind speed and our cloud cover. We have an increase from 6 miles per hour to 15 miles per hour of wind speed, and our cloud cover went from sunny with no clouds to 50% cloud cover, so partly cloudy. Now, if you look, the heat index stayed the same at 105 degrees Fahrenheit, but you'll notice that wet bulb globe temperature did drop 3 degrees due to that wind speed and cloud cover. And what this illustrates is, in the heat index, you're only taking into consideration the ambient temperature and the relative humidity. Whereas that wet bulb globe temperature, you have more things being factored into it, wind speed and cloud cover. So that actually reduced the wet bulb globe temperature, which reduced heat stress on the employees. So this is important to know just because there are more factors included in the wet bulb globe temperature. And if you look at the values, just due to the nature of it, the wet bulb globe temperatures will always be lower than the heat index, but they're also using a different recommendation on ranges. Or if you go back a few slides, you'll notice there's yellow, orange, red, purple for low, medium, high, extreme. Wet bulb globe temperature has that as well. It's just the values are slightly different because of the more factors. So in this case, 105 degrees Fahrenheit, it would be in the range of 85 to 88 degrees in wet bulb globe temperature. So wet bulb globe temperature is not communicated out very much currently from the National Weather Service or on heat stress apps. Or if you look on the app, you get the feels like temperature, it's a heat index. That's because it's relatively newer, it's more complex, and old habits die hard. So we're going to see that heat index around for a long time. And as we go through this, just for these examples, I'm going to use the heat index because it's easier for employees to understand, and it's just more readily available and accessible. If we can make some criteria based off the heat index, that may be advantageous because it's more readily available and people recognize it more. So wet bulb globe temperature is a thing. You'll be seeing it more and more in the future, especially if this OSHA standard gets published. So know that that is coming, and there are differences in how those values are calculated. So we've talked about the metabolic rate, or the heat gain from your body. We've talked about the heat gain from the environment and how that's measured. And we're going to talk about the output of the heat loss from our body to the environment. So as I mentioned, our body has natural processes that allow it to cool itself off, sending blood out to your capillaries to create more surface area. So that way, when you sweat, your body can cool itself by evaporative cooling. Now, there are things that can impede that or affect that. Thick and heavy clothing. If you wear thicker and heavier clothing, that's going to insulate your body more, and it's not going to allow for your body heat to dissipate as quickly. We also have temperature and humidity. The higher the temperature, the higher the humidity, that makes it more difficult to cool off just due to that high ambient temperature. And the higher the humidity, the higher the air, or the higher the moisture in the air content, makes it more difficult for that sweat to evaporate. And lastly, lack of hydration, which ties directly into personal factors. If a person is not properly hydrated, they're not going to be able to properly sweat. And dehydration just starts that spiral effect of not being able to cool, not being able to have or utilize electrolytes and those things. The other thing is personal factors. There are everybody's health status is different, and there are things that can affect a person's ability to cool itself off due to medications, medical conditions, personal choices, or somebody comes to work in the morning and they slam a couple of monsters, the caffeine and all of the ingredients in that can put a person at risk. And medications, if you think about it, some examples of just even allergy medication. Some people, if they take a simple allergy medication, it can disrupt their body's process to properly sweat. So just as something as simple as an allergy medication can have an effect. Now, a lot of time personal factors, we may not be able to control them because it's a person's health status, but we can provide education to inform so that way they can have conversations with the personal physician and work with them on how you can provide a good environment for them. So let's talk about how we can mitigate heat stress in the work environment. We've talked about our inputs and outputs. We have two inputs, body heat and heat from the environment, and we have an output of heat loss from our body to the environment. So let's look at ways on how we can positively impact the output and the input. So the metabolic rate is essentially the workload and how hard a person works. If you can find a way to reduce the physical demand for the work, you and there would be able to reduce the metabolic rate and lower the body heat generated from working. As I have in the photo here, using a tractor and a feeder wagon to feed livestock instead of carrying buckets of shell corn or feed or hay, using mechanical equipment can greatly reduce that workload. Using tractors, carts, mechanical equipment, conveyors, anything you can do to shift that workload and the movements from your employee to some type of mechanical device or aid. So that way, during the high heat environment, their body is not generating the heat from that physical exertion. There's also work rest schedules, and we see this recommended quite frequently, but in high temperature environments, you'll see some recommendations of working 15 minutes and taking a 45-minute break. Well, if you're working in dairy parlor, you don't get the option of taking a 45-minute break if you're in the middle of a cycle. So that may not be practical, but if we can reduce that metabolic rate, if we can try ways to minimize the workload, or if you have enough labor staffing, you can let people take a quick break and cool off every hour. That's always welcome as well. So essentially, we're trying to reduce the intensity of the work that your employee perform. And as I said, when we look at exertional heat strokes, which is the most common heat stroke in the work environment, if we can find a way to reduce their exertion and make the work more efficient and lower demand on our employees, we lower that risk of putting them at an exertional heat stroke. So workload management. Are there things you can do differently? Can you design a facility differently? Do you have a parallel parlor, carousel parlor, or do you just have a traditional parlor? And are there ways how you can design the facility to be more efficient to where your employees can do the same amount of work, but less movements that they're involved with? So the work environment. Are there ways we can improve the local environment Now in your dairy parlors, your dairy barns, you already have some heat stress mitigation techniques put in place for your cattle. You may have misters, you may have fans, and all of that is in place for your cattle is to keep them cool, because if they get too hot, your milk production goes down. So you already may have some heat stress mitigation things in place for your cattle. Is there a way you can adapt those strategies, or do you already have them that can also work for your employees? So how can you improve the local environment? Well, number one, airflow. If you've ever been in the loft in a barn stacking hay bales for an hour or two, and it's in the shade because it's in a barn, but there's a lack of airflow, and you get done stacking the bales, and then you climb down out of the loft and you go outside, even if it's 95 degrees, the end of July, high humidity, you walk outside of that barn and it feels really good, almost feels like air conditioning. Well, that's because you introduced the breeze and the airflow from outside. So, is there a way you can improve the airflow? Fans are the most common example. Shade. If you send your cattle out to pasture, sometimes there's trees out there, or in large cattle yards, you see the mesh in the middle of the yard to provide shade for the cattle. If we have people working in a fixed environment or fixed location, an environment, if it's not indoors, can you provide a tent? Is there a way you can provide shade so that way they're not in the direct sunlight absorbing that solar load? Of course, if we could, air conditioning would be fantastic, but that's not always practical or available when we're talking about large scale buildings. That's why we see large industrial fans on most type of large livestock producing facilities. And misters. Misters are in place to help provide evaporative cooling for livestock and cattle. Now, the one thing that also helps with misters is if you're using water that is cool temperature, if you're pulling it out of a well, and let's say that temperature is 55 degrees Fahrenheit, you're able to cool the local environment just due to the heat transfer from the environment to that cold water, and you're also aiding in that evaporative cooling for people. Now, there is a caveat to that, is it may work great in cattle in hot temperatures because you're providing that water to help them cool off since they can't really sweat much on their own. However, humans, we do have the ability to sweat. And if we start to get an environment that is too humid or too much humidity, and we aren't able to properly sweat, then that could be a detriment. So typically humans, once we start getting beyond 60% humidity, we start to feel pretty uncomfortable. And the higher you go, the more uncomfortable and the more difficult it becomes to sweat and cool yourself off. And one of the other things you can do is change your schedule so that way people aren't working in the heat of the day. Or if there's things that can be done in a cab tractor with air conditioning or activities that can be done in an air conditioned environment, can you change your work schedules so that way all the work that needs to be performed outside or in the hot environment can be done when it's not during peak heat time temperatures? So usually we see the recommendation anywhere between 2 to 5 p.m., depending on your exact location. So if you can schedule the work or start earlier, so you're done at 2 o'clock instead of 5, or adjust your schedule or do it in the early morning or later in the evening, so that way you're not working in that high temperature. That also is a really good way, but it's also not always feasible depending on your certain situation. So there are a lot of ways we can do to improve the local environment for our employees, but not every solution is going to work for every job task, every area. From your dairy parlor to another dairy parlor, configuration is different, design may be different. So we listed a lot of these ideas for the work environment. Not every one of these may be applicable to you, but at least here are some ideas of how you can improve the conditions of the local work environment. And it can be as simple as providing fans to give some airflow to help cool people off. And let's talk about the output, the heat loss from our body. So how can we improve people cooling themselves off by sweating from the heat loss from the body? Well, number one, we need to make sure our people are properly hydrated. Hydration is key. If a person is not properly hydrated, they're not going to be able to properly sweat. So what you'll see in a lot of recommendations, especially with the new proposed standard as well, is providing hydration stations, having cool potable water or sports drinks available for employees to have access to. And this is also beneficial so that way you can help ensure people are staying hydrated during work hours, just because you don't know what they may be doing outside of the work hours and they may become to work dehydrated. So you want to make sure your people are properly hydrated. Clothing, thin, lightweight, moisture-wicking clothing. Moisture-wicking clothing, what it does is it helps pull the sweat from your skin and spreads it out over a larger surface area. So that way it can cool off a larger portion of your body. Now, if you look at agriculture workers down south, Southern California, Texas, down into Mexico, you'll notice they're not wearing, these short, cut off shirts or anything like that. They're wearing lightweight, long sleeve shirts and pants and large breathable hats to keep that solar load off of their skin. Creates a small barrier so that way you're not absorbing as many UV rays. We're talking about heat stress, but sunscreen and protection from the sun is also paramount. And clothing is one of the best ways to prevent being exposed to those UV rays in addition to sunscreen and other things. So light long sleeve pants and hats are really helpful in that. The caveat being, if you're working around rotating equipment, tractors, and PTOs, you don't want to wear baggy clothing. You want nice fitting clothing and nothing that's baggy that can get wrapped up in a rotating object. And lastly, what we've seen in the more recent years is an assortment of personal protective equipment or PPE that has been designed to aid people in staying cool. I have here an image on the screen. These are called chilling towels. And what they do is you soak them with water and then you wring them out and you put them around your neck or your head, and it helps cool your body off because the material allows it to evaporate quickly. The quicker you evaporate that moisture, the quicker it pulls the heat away from your body. So we've seen a lot of PPE become available that helps evaporate that water or your sweat. So not only is this helping evaporate your sweat, it's actually providing moisture to evaporate in that towel. So there's all kinds of cooling PPE that we're seeing come to the market. So one of the other big things we need to talk about that kind of covers multiple inputs and outputs is acclimatization. Per OSHA, most outdoor-related heat fatalities, up to 70%, occur within the first few days of somebody working in a hot environment. That's because they're not acclimatized and their body is not used to working in those hot environments. Our bodies have this great ability to adapt to our local environment's temperatures. We were just talking before this webinar started of We had a few days in mid 90s, 100-degree heat indexes, and right now it's about 68 degrees outside, and it almost felt chilly. Well, the reason why is because our body was starting to acclimatize to those hot temperatures. We see this with our bodies typically every spring and every fall going into winter. In January, it's negative temperatures outside, it's cold outside. And then it gets to be March and it hits 40 degrees Fahrenheit outside. Here on campus, we may see students walking in shorts, or you walk outside like, oh, wow, this is really warm outside. And you may shed a layer. Instead of having a coat, bibs, and hoodie, you may just drop down to a hoodie and bibs. Now, let's fast forward to October. We have the first few times it gets down to 40 degrees Fahrenheit at night. That 40 degrees feels very chilly, very cold to us. Well, in both scenarios, it's 40 degrees outside, but our bodies are acclimated to the warmer or colder temperatures. In the winter, our bodies acclimatize to the colder temperatures. So when we see that increase in temperature, it feels warm. It feels good to us because we're used to those colder temperatures. And on the reverse side, when we are exposed to higher temperatures over a long period of time, when we experience those cold temperatures for the first few times, it feels significantly colder. And so our bodies have the great ability to adapt. And if there's one thing you should focus on for new employees, is it is allowing them to acclimate and become acclimatized to their environment gradually over time. And so we'll talk more about what gradually over time means. And so to allow people to acclimatize, you'll find a bunch of different recommendations, but the most common one is to start a new employee and not allow them to be exposed to a high temperature for more than 20% of their first day, and then no more than additional 20% for the consecutive days. So an example I have here is if you have a new employee that has not worked in a hot environment, a warm environment before, you want to have an acclimatization plan to allow their body to adjust and get used to those warm temperatures. So an example plan here is on day 1 and 2, you're going to cap them at 20%, assuming an 8-hour day, and that would be 2 hours. So for day 1 and 2, they're only going to be working in that hot environment for 2 hours. Days 3 and 4, you're adding another 20%, so 4 hours. Day 5 and 6, 6 hours. Day 7 and 8, 8 hours. So this plan encompasses a week and a half of allowing your employees to acclimatize, so that way they don't get exposed to that high heat and physically exert themselves, putting themselves at risk. So that's an example of acclimatization plan. And you look at the stat I just listed on the last page, that up to 70% of heat-related fatalities on the work start within the first few days. Allowing for acclimatization is paramount in a heat stress mitigation. The other thing you'd want to do for an additional control is make sure your employees are trained on heat stress, prevention methods, first aid, and then emergency procedures if somebody does start to have an emergency due to heat. So let's put this all together. We covered a lot of things so far. And really, I want you to remember your inputs of heat stress and your outputs. You have 2 inputs, 1 output. You have heat gain from your body, heat gain from the environment, and then your heat loss from your body to your environment. How can you positively impact an input or an output? So when we put it all together, the biggest thing is you need to have a plan in place for when temperatures get hot. When people are exposed to higher temperatures, performance naturally goes down, just due to the stress on the body. You need to ensure your employees are trained on heat stress, prevention methods, first aid, and emergency procedures. And then in your plan, identify potential mitigation strategies that you could utilize and use a phased approach depending on what the heat index values or what low temperature values are. And on the next slide, I have an example of what that mitigation plan may look like utilizing heat index numbers. So this is just an example, but let's say you have a heat stress plan that you're putting together. You have training, you allow your people to acclimatize at the beginning, and what are additional controls you may put in place when the heat index starts to increase. So 85 degrees Fahrenheit heat index, you're going to ensure that acclimatization plan for new workers is implemented. When the heat index hits 90 degrees Fahrenheit, hydration stations are going to be provided. You're going to have reminders, communication, pre-shift briefing of it's going to be hot out, what the heat index is, maybe offer cooling PPE. Then as we approach a heat index of 95, we're starting to approach the temperatures where maybe we need to start changing the routine and the intensity of our work because our body's not going to be able to cool itself because it's getting so hot out. And if we're working at a heat index of 100 or more, maybe we need to change those work hours. It's time to alter our routine to avoid the peak heat of the day. And maybe require the buddy system so that way nobody is working alone in the heat. People can keep an eye on each other. If they start to notice some heat stress symptoms in another employee, they're able to recognize that sooner than the person exhibiting those symptoms may be able to. And so this would be a cumulative plan. So you wouldn't have to do all these at once, but at 85, you're going to do this. 90 degrees, you're going to also do this. And so this is just an example phase mitigation plan based on the heat index. Just because in some situations, it may not be practical to do everything year round. And so it's a good idea to have what mitigation strategies are available to you and what is the practicality in applying those to your situations and how long those controls will need to be put in place. It may be we have a heat index of over 100 degrees Fahrenheit for 3 days. Well, we may be able to change our work hours to 5 a.m. to 2 p.m. for 3 days. That's not a problem for 3 days, but that may not be feasible for a week, 2 weeks, 3 weeks. So that is why I like the phased approach on this. So that way you can determine what's feasible at different temperatures and based on feasibility for your unique situation. And so it's been right about 45 minutes here. I want to make sure we have plenty of time for Q&A. So a quick recap of what we discussed. We defined heat stress. We identified the contributing factors of heat stress. Those are your inputs and your outputs. And we also went over some solutions on how we can prevent heat stress for employees, really focusing on how you can positively impact an input or an output. So with that being said, what questions do you all have?
I would invite everybody to go ahead and type in the chat box if they've got any questions. I will go ahead and kick off. You'd mentioned air conditioning. Does moving in and out of air conditioning contribute to heat stress? I know that was grandmother's contention for many years.
Yeah, so for a person to properly acclimatize to a hot environment, they need to be in that hot environment for a minimum of an hour. So if somebody's in a hot environment for an hour and then goes into air conditioning to cool off, that shouldn't affect their ability to acclimatize and it shouldn't affect them too much. Now, if you're going in and out hot and cold and the frequency is less than an hour, that can definitely be more challenging for a person because your body doesn't know which way to acclimatize to. But if you're changing those environments less frequently than an hour, your body can acclimatize to the environment. And it used to be thought that if you work outside all day and then you go home in air conditioning, you lose your acclimatization. but research has shown that that's not true. And what that does is that actually increases the range of temperatures that your body can acclimatize to. So during the summer, if you go home and your house is 70 degrees and you work outside in 100-degree heat, you have a wider range for your body to acclimatize. And what that does is your body will start sweating at a lower temperature. So going in and out of air conditioning, depending on your exposure in each environment, your body should be able to handle that as long as it's not bouncing in and out for very short periods of time.
And it sounds like the sweet spot is an hour at least. You've got to be out.
Yes, if you want to have your employees acclimatize, they need to be in the hot, or if you're working in a cold environment, meat processing facilities in their cool rooms or food distribution, they need to be in that cold environment for at least an hour for your body to start the acclimatization process.
Very good. Yeah, I'm not seeing anything in the chat box. I've got another question here. Is sunburn part of the heat stress or contribute to it?
So that's an excellent question. So sunburn essentially is a burn to your skin from UV radiation. And after you get burned, if you feel that, you will feel the heat radiating from your body. So does it directly contribute to the total heat stress load? After the sunburn, I'm not quite 100% sure on the answer to that. All I know is that it is very uncomfortable because once you get sunburned, if you try to cover it up with clothing, it gets very uncomfortable. And so therefore people don't want to cover it. They want to leave it open and let it air out. So a direct answer for the question on can sunburn contribute to the heat load, I'm not 100% positive on the answer to that, but I do know that sunburn makes it very, very uncomfortable for employees if they do get it. And it can prevent them from taking proper protocols, wearing longer clothing, or wanting to be out in the warm environment. So I'm not 100% sure on the technical answer for that, but I do know sunburns make it more difficult for people to work in warm environments once they receive the sunburn.
Got a question here. Do you have a resource that can be accessed to help with training of heat stress with employees?
Yeah, so if you're an ISU employee, we have a heat-related illness training on Workday Learning. And so if you go on to Workday and you go to Workday Learning and Discover in the EH&S catalog, you can find the heat-related illness training and assign that to your employees.
Then you also have a web page, is that correct?
Yes, we have a web page that was shared in the chat. If you go there, that has a lot of our resources, and at the bottom of that page, it has a link to that heat-related illness training.
Okay. You mentioned airspeed and moving air. What's the optimal air speed to have? Is there something that we should be targeting?
That is an excellent question, and the answer is it depends. It depends on the design of the facility, where you're at, temperature. So I don't have a predetermined velocity of airspeed to where it may be comfortable, just because there are too many factors to give a want or a blanket statement on that. I don't know what that would be if there was one, if they did have it. You just don't want it to be too hard to where it's blowing people off their feet. So a lot of factors that would go into that. And I don't know that if there's a specific recommended velocity for airspeed for humans to cool off in hot environments. I know a lot of dairy parlors have fans and ventilation that are designed to cool that local environment. Placement of those fans, design, local ventilation for plenums for air coming in and out, placement of that. There's a lot of variables that would go into that, of what the velocity in that local environment is. And I don't know if there is a specific target for what would be comfortable in the heat for a person.
Very good. You'd mentioned long sleeves, light long sleeves, especially shirts. They absorb sweat and help the body uh, cool off. Is color a factor?
That's an excellent question. I was actually reading some research where they were saying darker colors may be warmer on the surface, but cooler underneath of the surface of that. And I haven't read enough research to say that that is accurate, but typically we see recommended light color clothing. So that way it is reflecting more light away from your body than absorbing it. So recommendation would be to stick with lightweight, light colored clothing in those warm environments. So that way the clothing in your body would not be absorbing all that heat.
Okay, I would invite folks to go ahead and put a question in the chat box. Uh, One question that I've got here is obviously working in the sun outside is different than working under a cloudy sky.
Mhm.
But does it make a difference when you're actually in the shade?
So if from sitting in the sun and sitting under a shade tree, those would effectively be the same. Just because the sun rays are being blocked, whether it be clouds or via under a shade tree.
Okay. If an employer is interested, where can you find the WBGT numbers?
Yeah, so I was actually talking with National Weather Service about this. So they actually have a web page that you can go to where it has a wet bulb temperature forecast. And if you go to the Tulsa, Oklahoma National Weather Service webpage, they have that wet bulb globe temperature calculator. The slide where I had scenario 1 and scenario 2, I got that from there. I can have, I can send Fred the link and have him send that out to everybody of where you can find the National Weather Service wet bulb globe temperature forecast. I just recently found out about that when I was having a conversation with them, but that is available. I can stop sharing my screen here and I can actually drop that link in the chat here if you give me a second.
Well, I had one other question that I was thinking about, and just as people are looking for cooling clothing, is there a particular place that you would direct people to purchase those things? Or I know there's a lot online, there's a lot of stores, but I didn't know if there was like a direct place that here is a specific place for employee clothing.
Not that I could recommend off the top of my head. Just lightweight, moisture wicking clothing would be the recommendation. Whether that's Amazon, Kohl's, Central. I don't think Central Stores on campus has any anything that'd be moisture wicking from any large retailer would be appropriate. And I just dropped in the chat. If you click that link, it will take you to a map of the US, and there is a drop down box for different values. If you select wet bulb globe temperature, it will show you what the forecast is. And I'm going to visit it and I'm going to pull it up here real quickly. And then I'll share my screen. And so here, this is the website I linked in the chat. And if you go here, this is the map of the United States. And if you go to this column right here, right now it's displaying maximum temperature. You can go down and select wet bulb globe temperature. And it has a scale: low, elevated, moderate, high, extreme. And there's a little sliding scale up here. And so right now, as we mentioned, it's cool in Iowa, but if we can go back today, let's see if it'll let us go back. So you can see how that chart was changing as I went back in time. Let's see how. And this just gives you a map of the wet bulb temperatures. And since it cooled off today, we're going to be in the green, but you can slide this little bar up here and get a sense of what the wet bulb temperature will be. And so there you can see tomorrow afternoon, you can see we're going to start going back up into the yellow and orange, where today we're in that green. And it only goes out a couple days, but there you can see now all of Iowa is in the orange, and we're seeing a few specks of red. So that tool is available, and I just dropped that in the chat for everyone.
Thank you very much, Cody. We'd like to thank you for presenting some really great information that'll help us keep our employees safe. We would invite folks to go ahead and, listen to this again, or have employees listen to it once we get it put up on our website. We are recording and archiving this, so it'll be permanently on the ISU Dairy Team website. Again, we'd like to thank everybody for attending and look forward to having them come back next month. Thank you, Cody. And that concludes this month's program.
Thank you, everyone.